Hi YouTube, this is Hasib Afsar. I'm going to talk about mobile app security exploits and how you can fix them. And today I'm going to talk about App Snapshot Exploit. So this is a very popular security exploit. So before I get into the exploit itself, to demonstrate that, what I'm going to use today is iPhone simulator, and in that I'm gonna have two apps. So one I call this is App Monitor app, which is basically my spying app, and then I have another app called Snapshot Exploit app, which is actually the victim app or the target app. So as far as the exploit is concerned, what we're going to do here is so let's say we go into this app, and let's say you're building this app for your company or your HR, where it enables your company employees or someone else to look into their profile information and also the payroll information. So the basic idea here is that whatever the user does on this app, whatever the activity, that can be pretty much seen from this uh, app monitor app. So with that said, I would also like to give you some context on why I'm using the iPhone simulator here and what we have here as well. So as you can see here, this file system here is nothing but, if you go into this path, I mean with your username, you will see something called developer, and under developer you'll have your core simulator. And if you go in core simulator devices, and then what you're gonna see is pretty much something like this. So since I'm using my simulator right now, with this session, so it has created another unique folder. As you can see, the timestamp, with some unique ID. So if I go into this, I mean, so what it is doing is basically it is simulating the iOS operating system, the file system here basically. So if I go in here, I can see the root folder, and then if I go into this, I can pretty much explore the whole file system. So coming back to why I'm using iPhone simulator, because it is pretty easy to simulate, pretty easy to illustrate that. With the actual device itself, I cannot show you the actual file system because it's kind of abstracted or hidden. So even though, like, if you have the iTunes, there is a workaround using which you can pretty much explore the file system. I mean, there are tools and utilities out there from using which you can do that. But I'm not using that, but I'm just using the iPhone simulator for the sake of easiness. So with that said, let's explore the file system itself here. So as I was mentioning, assuming that this is your root folder, so if you go in here, you will see a couple of other folders here. So what we will be interested for the sake of this demo is this folder container and also the library. So if you go in container, there's a folder called data, and then if you go in data, there's a folder called application, and again you will see a set of unique IDs created as folders. So what is this? This is nothing but like the application that are running on the device or simulator. They are given a unique ID, and that with that unique ID, a folder is created. This is done because the operating system has to maintain the state of the application and also the runtime data of the application. So, and all of your runtime data and the state of the application pretty much kind of gets captured here. So that's pretty much what it is. And as part of the state of the application and the runtime data, as part of this exploit, what we're going to look at here is like the snapshot that it is taking on your recent activity. So I think this is more than enough as far as the context is concerned. So let's jump into the demo. So what we got here? we got a simple app where we have two screens where we have some personal information, and we are switching between screen one after the other. So I have also opened up the respective folder. So as you can see, so if I go into the background mode, let's see what happens. It wrote something here, right? So what did it write here? So what it did was it took a snapshot of my last viewed screen and it saved it here. So why did the operating system did this? So it did this for a reason. So when the user comes back to the application, the operating system, the first thing the operating system is going to show you is this screenshot. It does this because it wants to initialize. It needs to buy some time to initialize the UI components behind the scene. So this is a very marginal delay that the user will experience, but the operating system uses this pretty much to just give the user the feel that the application is up and running and pretty responsive. So the downfall of this is that anyone who knows the file path can pretty much misuse this. So how this can be misused is like if you're taking an iTunes backup, so all of this data gets transferred to your system, and if that system is kind of compromised, so then this data kind of just gets along and gets compromised. The other way you can read this information or access this information is like having another kind of app which basically explores your file system. Technically you cannot distribute this from the App Store because the kind of APIs, private APIs it is trying to access, and the kind of file path it is trying to access, Apple would reject this outright. But there are different means and mechanism you can distribute this even on a unjailbroken, not jailbroken iPhone. So you can do like a OTA or something like that. So assuming that this gets installed, what you can do is, so I've just written a very simple file browser here. So what it does is basically it pretty much looks for this file path or this folder here and copies the PNG file into its sandbox and tries to display that here. So let's give it a try. So what I'm going to do is I'm just going to look for this path. As you can see, so here is the path. Just going to copy this. Let me delete this and let's go and paste this. I'm just looking for the folder, and anything within that folder I'm just copying. So I'll just remove this file name. Okay, so I think I need to run this again. Let me run this real quick. I think there's something wrong with the file path. Let me make sure that I'm copying the right one. All right. Okay, I have a different file path here. It's a bit funny though that it's taking my last copy but not the latest one. So just doing a command V. Okay, now I gotcha. I hope this should work this time. Fingers crossed. Ah, there we go. So it's working. So just to prove this that I'm not bullshitting about this, so it is actually reading from there. So I'm gonna go to that app and I'm gonna change the screen and come back again and try to view this again. So it should show me the last viewed screen, right? Let's go back and change this to the payroll information. Let's go back here again. There we go. So it's showing me the last viewed screen. So as I told you that every time I press on view file, what I'm doing is I'm copying that file. So just to show you that how it's working behind the scene, do watch here. I mean, I'm gonna get a new entry, so there should be a file copy. As you can see, I just copied one file. If you have missed that, let me do this one more time. There we go. So this phenomena just doesn't happen just for your app. I mean, interestingly, iOS is doing this for like all of the application, even for the default system app. So to give you an example, I mean, using these same techniques, somebody can pretty much compromise your message app, or like sneak into like what you're texting and things like that. So to give you an example, what I will do is let me show you the file path of like where your message snapshots are getting stored. I'm going into library, and there's something called caches here. And if I go in here, there's a folder specifically named snapshots, and here this uses this path basically to throw in the system app snapshots. So as you can see, there is one for the messages app here. If I go in here, I'll go into this folder, and then let's say I go in. So in the simulator, as you can see that you get like a simulated messaging platform. So I can message to this guy, and this guy can message to this guy. It's a bit funny, but just for the sake of simulation, I'll use this. So if I go here and then I'll say like, hey, hi Kate, let's catch up for dinner tonight. So, and then I go in background. Now you'd have seen this here, that it just did a write here to the file system. What did it write? So it wrote this new screenshot. So now using my app, what I can also do is I can read the messages. So let me prove that real quick. So what I'm gonna do is I'm just gonna copy the file path again. As you can see, let me copy this. Let's go back here. Let's select this, and yep, there we go. So you can also view the messages. So yeah, I mean, that's how it is. Now you might ask like, well, how do we fix this? To answer this question, it's a very simple fix. How it works is that you go into your application delegate, uh, and then you have your delegate methods here, like will enter foreground, did enter background. So to show you what you can do, let me go to the snapshot exploit, which was a wiki map. And here in the did enter background, what I can do is I can pretty much throw in a splash screen, which could be just anything from an icon to anything, which would be captured instead of your actual app sensitive screen or data. So let's give it a try. Let's build this up and let's run. Let's see what we got. Okay, so I have this here. Now let's go back. Since we have a different file path, I just want to copy the one for that app. So what I'm going to do is I'm gonna copy this until the downscale folder. Now let's go to the app monitor. Let's select this. Let's paste this. So this is what you're gonna see. So this is a custom splash screen that I added. So whenever my app goes into the background, so what I'm trying to do is I'm throwing this splash screen first. So the what the operating system is capturing is just my splash screen. So I hope this video is helpful, and you would be using in your day-to-day projects. Do watch out for more videos to come. Thank you so much.